Welcome back to the second video of the course. In this video, we will look at the history, the present-day use of WLAN, and some fundamentals related to it. Let's get to it now.
This is probably the section that everyone wants to skip because, as most people say, history is boring. Still, let's not listen to what most people say, and we will go through this section together so that we are able to better understand the origins of WLAN and its current implementations. This will help us understand the importance of WLAN and better relate to the principles that we will be covering further in the course. Way back in the 19th century, many inventors and scientists, including Michael Faraday, James Maxwell, Heinrich Hertz, Nikola Tesla, David Edward, Thomas Edison, and Marconi, began to experiment with wireless communications. These innovators discovered and created many theories about the concepts of electrical magnetic radio frequency, nowadays called RF. Surprisingly, wireless technology was first used by the US military during World War II to transmit data over an RF medium using classified encryption technology to send battle plans across enemy lines. In 1970, the University of Hawaii developed the first wireless network called AlohaNet to wirelessly communicate data between the Hawaiian Islands. The network used a LAN communication OSI Layer 2 protocol called Aloha on a wireless shared medium in the 400 MHz frequency range. In the 1990s, commercial networking vendors began to produce low-speed wireless data networking products, most of which were operated in the 900 MHz frequency range, and by the end of this decade the small office home office SOHO marketplace was established, and then there was wireless everywhere around.
Again, this is a not so interesting section, but we ought to know who's behind the wireless industry. The CWNA study guide by Tom Carpenter accurately describes the type of organizations that are involved. These categories include regulation, standardization, and compatibility. The Federal Communications Commission (FCC) and the European Telecommunication Standards Institute (ETSI) are examples of regulatory bodies. The Institute of Electrical and Electronics Engineers (IEEE) is an example of a standards development organization, and the Wi-Fi Alliance is a compatibility testing and certification group. It is very important to understand how these organizations within the wireless industry work together. As an example, consider the interdependency between the FCC and the IEEE, or the relationship between the Wi-Fi Alliance and the IEEE. The FCC sets the boundaries within which the IEEE may develop standards for wireless. The Wi-Fi Alliance tests equipment made by vendors to certify it as being reasonably interoperable. These three organizations provide regulation, standardization, and compatibility services for WLAN technologies within the USA. Similarly, other organizations might be involved in other countries. Let us understand some of the well-known organizations in this field. The FCC. The Federal Communications Commission regulates interstate and international communications by radio, television, wire, satellite, and cable in all 50 states. Also the District of Columbia and US territories. It is an independent US government agency which is overseen by the Congress. The ITU-R. The ITU radio communications sector is one of the three sectors of the International Telecommunication Union and is responsible for radio communication. Its role is to manage the international radio frequency spectrum and satellite orbit resources and to develop standards for radio communication systems with the objective of ensuring the effective use of the spectrum. The IEEE. The definition of the Institute of Electrical and Electronics Engineers is quite vast, so for the reference of this course, they are an organization which makes standards. The IETF. The Internet Engineering Task Force (IETF) develops and promotes voluntary Internet standards. In particular, the standards that comprise the Internet Protocol Suite. Unlike the IEEE, the IETF is an open standards organization. The Wi-Fi Alliance. The Wi-Fi Alliance is a non-profit organization that promotes Wi-Fi technology and certifies Wi-Fi products if they conform to certain standards of interoperability. The ISO. The International Organization of Standardization is an international standard-setting body composed of representatives from various national standards organizations. We talked about the Wi-Fi Alliance in the previous section and something came across my mind. What does Wi-Fi stand for? I've seen that this discussion is missed out in presentations, tutorials, and many of the trainings. My friend George Stefanik, and a wireless guru as he is popularly known as, has put this discussion on paper and has really made a point. In short, and in his words, Wi-Fi is actually just a made-up word, and it definitely does not mean wireless fidelity. Be sure to go through the complete article at the mentioned URL. You can find this at the Airheads community website. To check out more of the wireless guru's interesting articles, drop by his website, my80211.com. You can find some great reads there. We all must have heard about the core, distribution and access layer. If not, they are defined as follows. The core layer. This layer is considered the backbone of the network and includes the high-end switches and high-speed cables. This layer of the network does not route traffic at the LAN. In addition, no packet manipulation is done by the devices in this layer. Rather, this layer is concerned with speed and ensures reliable delivery of packets. The distribution layer. This layer includes LAN-based routers and Layer 3 switches. This layer ensures that packets are properly routed between subnets and VLANs in your enterprise. This layer is also called the workgroup layer. The access layer. This layer includes hubs and switches. This layer is also called the desktop layer because it focuses on connecting client nodes, such as workstations, to the network. This layer ensures that packets are delivered to end-user computers. Its defining characteristics generally revolve around either high port density or the ability to overcome physical last-mile type challenges like wireless 802.11 or remote access via modems or VPN. The different types of wireless communication mainly include IR wireless communication, satellite communication, broadcast radio, microwave radio, Bluetooth, Zigbee, etc. In the present days, wireless communication systems have become an essential part of various types of wireless communication devices that permit the user to communicate even from remote operated areas. Let us look into some of the communication principles. A carrier signal is a transmitted electromagnetic pulse or a wave at a steady base frequency of alteration, on which information can be imposed by increasing signal strength, varying the base frequency, varying the wave phase, or by other means. This variation is called modulation. This modulation that we talked about can be achieved by certain keying methods. Modulation is a general technique of shaping a signal to convey information. Several keying techniques exist, including phase shift keying, frequency shift keying, and amplitude shift keying. Let us consider something that we use very frequently, Bluetooth. This uses phase shift keying to exchange information between devices. So what are these keying methods? Frequency shift keying is a digital modulation scheme that conveys data by changing the frequency of a reference signal. Amplitude shift keying, on the other hand, is another digital modulation scheme that conveys data by changing the amplitude. Phase shift keying is a digital modulation scheme that conveys data by changing the phase. We need to understand frequency, amplitude, and phase to better understand what these keying methods are. Frequency describes the number of waves that pass a fixed place in a given amount of time. So if the time it takes for a wave to pass is half a second, the frequency is 2 per second. If it takes 1/100th of an hour, the frequency is 100 per hour. As waves travel, they set up patterns of disturbance. The amplitude of a wave is its maximum disturbance from its undisturbed position. Take note that the amplitude is not the distance between the top and the bottom of a wave. Phase, on the other hand, is the degree of wave generation and propagation. I hope that clears things out. In this video, we have looked at the history of WLAN, the organizations responsible for the wireless standards that we use today, the present world implementations of wireless systems, and some fundamentals. See you all in the next video. Stay tuned.